Hello and welcome to episode 3 of this series. In this episode, I am going to talk about JWT authentication in our API. So using JSON Web Tokens to authenticate the user and to kind of extract the claims or the roles of that user to do the authorization. So we are going to create our login API that will be responsible for authenticating the user. We are going to generate a JWT token with our user roles, and then we are going to add a middleware to our API, JWT bearer authentication middleware, which will be, which we will need to authenticate and authorize the user using tokens. And then we can test the login feature of our API using a client app like Postman or Hopscotch or Fiddler. In this case, I am going to use Hopscotch. So let's talk about JWT. We already, explored JSON Web Tokens or JWT in episode 2, but I want to briefly revisit this here. So as we discussed, JWT is a compact URL-safe token. It is not encrypted. You can encrypt it, of course. It is optional, but it is encoded. So the JWT kind of proves the identity of the user, so who the user is, and then carries the roles of that user, so it helps with authorization as well. And as we discussed again in episode number 2, JWT contains 3 parts: header, payload, signature. Header is the algorithm used to sign the token. It will contain the algorithm used to sign the token. Payload is, as the name suggests, the payload, so the data containing the user information like email, roles, etc. And the signature is the data that will be used to verify the authenticity of our token, whether the token is valid or the token has been tampered with. So when the server issues a token, sends it to the client will use that token to send subsequent requests to get access to endpoints, protected endpoints. So the token needs to be authentic. If it is tampered with for whatever reason, the API will detect that using that signature part. So the first thing that we are going to do is to add this piece of configuration to our app settings file. So this is, as you can see, the settings section for our JWT. And there are 4 important properties in this object, and we are going to talk about them. But before I do that, let me take you to my application. I have created a new branch for this episode number 3, and now I want to start with adding this piece of data to my application. So I am going to add my JWT settings. And I want to talk about each one of these different parts in more detail. So this section in our app settings is going to set up our JWT JSON Web Token information kind of. The application we will use these properties to issue and validate the authentication tokens, and these settings are important if you want to use the authentication scheme using JWT bearer in your ASP.NET Core Web APIs. Let's go through each property or each key in this object to better understand the reason or the purpose of each one. The first one is the key. So the key, as you can see, contains like a random string to sign the JWT. Do you remember I told you that the JWT is digitally signed? So we can, kind of detect the authenticity of our JWT. So if the server, issues a JWT and then the client tampers with that, our server is going to detect that. So this is the secret key used to sign the JWT. The JWT is going to be digitally signed. The server uses this to sign the token when it is going to create that token. Later, the same key is used to validate that token to detect whether the token has been tampered with or not. So this key needs to be kept secret on the server. In our case, we are hard coding it in our app settings file, but of course there are other techniques to protect this random string, and of course you shouldn't check this into your source control. It should be at least 32 characters for good security, you can come up with a random string as the key that is used to sign your JWT. The next key is the issuer. So the issuer is the entity that issues the JWT. So in this case, it'll be our API or your Auth server. So it gets embedded in your token as ISS or issuer. It's going to be a claim in your JWT token. And during the validation phase, when the server wants to validate the token, the app checks this issuer claim and makes sure that the value, which is Flywise API, matches what the setting in our application specified. So think of it as who created this token. The next part is the audience. So audience, as the name suggests, is the recipient of this token. So simply it could be the front app or the client application that is going to use the token. So it is stored as the auth or as the auth or audience claim in your token. And when again validating the token, your API checks whether this value is authentic, whether this matches the value that we've got in our app settings file or not. So Flywise users. So think of it as who is supposed to use this token. The last key is the duration in minutes. So this is the expiration time in minutes for this token. After this duration, after 60 minutes in this case, the token becomes invalid even if it is even if it is correct, it will be invalid. So the server will kind of invalidate the token. So this controls how long a user remains authenticated before needing a new token for the application. So in the JWT, this is set up as EXP or expiration claim in your JWT token. I have talked about, I have mentioned claims a couple of times here, like for example, the expiration claim or the audience claim, right? But let's talk about claims and how claims can help us with authorization and authentication. So a claim, as the name suggests, it's kind of a statement about a user or a subject. Sometimes when we talk about users in this context, we come across the word subject. So a claim is a piece of information, is like a statement about the user that represents some piece of information. It's essentially a key value pair that conveys data about that user's identity or other attributes. Some examples of common claims: sub. Sub is the subject identifier, so the user ID, right? Then you've got name, again the full name, user's full name, John Doe. You've got email, the email address of the user. You've got role, the user's role, admin or pilot. IAT or issued at, it is the time when the token was issued. And then you've got expiration, again the time when the token will expire. So different kind of claims, key value pairs. This is of course the key, right? These are the keys, and you've got some sample values here. So these will be inside of the payload of your token, and your application can use these pieces of data, these claims, to authorize the user. Why are claims important? So claims form the basis of identity in modern authentication systems. Instead of just knowing who the user is, claims provide additional information about the user. This info can be used for authorization decisions. What is the user allowed to do? Now, claims in JWT tokens. JWT tokens carry claims inside of the payload, the middle part, right? You've got the header, you've got the payload, you've got the signature. So when a JWT is validated, these claims are extracted and added to the user's identity. The name of the object is going to be claims principal. So this kind of represents the identity of the user. And then ASP.NET Core uses these claims with the authorized attribute and the policies and role checks that we will be implementing to kind of authorize the user and decide what the user can do in your application. What, for example, protected routes the user can access. Now let's compare claims and roles. So roles are a special type of claim. So the name is role, it's a claim, often used for grouping permissions. Of course, roles are very, they are, let's say, the simplest way that you can implement authenticate authorization with. But claims are, more granular, more, fine-grained. They give you a lot of control. So claims can be much broader, and they can contain any information, not just roles. So a role can be one single claim inside of your payload, the payload of JWT, I mean. So how claims are used in ASP.NET Core? You can access the claims of a user in your controllers or middleware using user.claims, or you can use them in your authorized attributes that you can apply to your endpoint. So authorized roles admin kind of checks whether there is a claim of type role in the token, and the value of that claim must be admin for that user to access that endpoint. And we can create custom claims as well. We can, for example, based on the domain of your project, you can create custom, claims like department, employee number, permission, and so on. Now let's create our JWT helper service. This is a service class, and we are going to create in our application. We are going to create a folder called services. Then we've got this JWT token service, and I am going to write the code as before. And then I am going to talk about this code. But by briefly looking at this code and by the, through the names of the different objects and this single method, you kind of know what this class will do. So generate token async is going to generate our token, right? But let's do something. Let me go ahead and add this class to our application, and then I am going to talk about it. So I've got to create a folder called services, and then I am going to add a class, and I am going to write the code for this JWT token service. I've got two dependencies, configuration and user manager. Based on our application user type, I'm going to inject these two. Then I've got this method called generate token async, which takes an application user and returns a string. So this is my symmetric security key. This is my signing credentials. Then I am going to get the roles of that user. I am going to create my claims. I need, the name identifier, email, and then the username. I am going to add those to my, claims. And then I am going to create my token using this class, JWT security token. I'm going to set the issuer audience, claims, expires, and signing credentials, and then I'm going to return this. So there are, I guess, namespaces that I would need to add. Header encoding selector. I don't know, maybe there is this typo here. Signing credentials, symmetric key, security key. Let me pause the video, fix these issues, and then continue. So I fixed the issues. One of the issues was with the type used here. So it was, it is supposed to be claim. And the other one was the issue with the encoding thing. So here. Anyway, I fixed them. Now let's talk about this code. So this class, as I told you, is the class that kind of encapsulates the logic to generate a JWT token. For authentication and authorization, we are going to generate a token and send it to our client. Now, first, let's examine the code portion by portion. First off, the constructor and the dependencies. So this service takes in two dependencies. So the configuration, because we need to read the settings we just added to our app settings file. So we need the key, issuer, audience, and duration in minutes, because we are going to use these when we want to create our token. And then the user manager application user, this is the custom type that we define as our identity user. And then the user manager, this again helps us with retrieving the roles associated with that user and the other pieces of information that we will require. The next section is this method. So this method is an asynchronous method. It'll take an application user as a parameter, and it will return a JWT token, a signed JWT token as a string, as you can see here. Next, check out this piece of code. So we've got this symmetric security key and signing credentials object. So these two lines of code the first one reads the secret key from the config and encodes it as bytes, and the next one is going to create a signing credentials using HMAC SHA-256 algorithm to sign the key. So if you take a look here, I am reading this portion of my configuration inside of my app settings file. So JWT settings key is going to be JWT settings key. I'm going to read this key, and then I am going to do what? I am going to create, a signing algorithm, HMAC SHA-256. And these are used to digitally sign the token. So now let's look at the next line of code. We are going to use our dependency user manager to get the roles associated with the incoming user, the user that we have received as our input parameter. So we are going to fetch all of the roles assigned to that user. We have already created some roles and some users in our application. Then we've got this portion of the code. So we are going to create a list of claims. So it creates a claims to embed in our JWT token. We've got name identifier, which is going to be the ID of the user. The user, again, is the parameter, the input parameter to this method. We've got the email, and we've got the name of that user. The user has some pieces of data associated with them, like the ID, email, username. We are going to create claims based on them, and then we are going to add a claim for each role assigned to the user with the claim types.role. So this is what this line of code is doing. So again, for each role that we are going to create like a claim based on that role, and we are going to add that claim. So right now, this claims as a list of claims contains the claims that we would like to include in our JWT token. Then comes the section which is creating the token itself. So the type is JWT security token. So this creates a JWT token object with the issuer and audience from our config file. So you remember these two keys in our token, right? Issuer and audience. To validate the source and intended recipients, the user claims and roles that we just created as a list of claims, and then the expiration time and the signing credentials. So the signing credentials, of course, is going to be the object that we created at the top here, credentials. So the token is created now. It is inside of this token object. Then we are going to return it. Finally, check out this line of code. It's going to serialize the token object into a compact string format suitable to be sent to clients. It's going to return JWT security token handler, write the token, and then the token, the object that we created. So this class, therefore, is responsible for creating tokens based on the information that we've got in our app settings file. The next part, of course, would be to register this class in our IOC container. So we're going to add this code to our program.cs. This line of code registers the JWT token service class with our DI, with our dependency injection container. And it means that whenever a constructor or a method asks for a JWT token service, the DI will provide an instance of this type. The lifetime is scoped, of course. It means that a new instance is created once per HTTP request, and the same instance is reused within the scope of that request. And again, why are we only using one type parameter here, right? Because mostly, with dependency injection, we are accustomed to seeing an interface and then the implementation of that interface. But here we're using one generic type parameter. So add scope T service is a convenience overload. It is equivalent to this. So whenever this dependency is needed, create an object of this type. So here the service type and the implementation type are the same. Therefore, you can use this, shorter syntax. You want to inject the concrete class directly, no interface abstraction, and you don't need to register a different implementation or abstraction. Now, let me go ahead in my program.cs. I need to add that, service to my, program.cs file. So I am going to add this. The next thing that we need to do is to configure our JWT authentication middleware. Again, in our app settings file, in our program.cs, we are going to, do some configuration for our, JWT middleware authentication using JWT bearer. Again, I am going to add this piece of code to my program.cs, and then I am going to get back to the notes and explain everything in full detail. So again, the next thing that we need to do is to configure our JWT configuration. And we're done. I just need to change this to encoding. And let's get to the explanation part. So this block, as I said, it's going to configure your application to use JWT token bearer token authentication, or JWT bearer token authentication with proper validation settings so that the incoming requests with JWT are correctly authenticated. There are different portions that I would like to discuss. First, this section. So basically, we are getting some settings for our app settings file, and then this is the key that we want from our app settings file. So this reads the JWT settings section from your app settings file, which contains the key, that super secret key, and the issuer, of course, and the audience and whatever. And then, of course, we want the key. We want the key. We are going to capture it inside of this variable, and we're going to use that key for token validation. Next, we've got this portion of the code. So we've got builder services add authentication, and you can configure your authentication with this, lambda, and then you are going to configure this like, with these two lines of code. So this is going to register the authentication middleware in your DI container. It's going to set the default schemes for default authentication scheme. So default authentication scheme is how the app will validate the identity of the user. So basically to authenticate the incoming tokens. And then you've got default challenge scheme. So default challenge scheme is how the app responds to unauthorized requests, like for example, sending a 401 response or unauthorized response to the user who is not authorized based on the request they are sending. So I am configuring my middleware. So using default authenticate scheme and default challenge scheme. Both are set to bearer, the JWT bearer token scheme by using the JWT bearer default authentication scheme. And then the next piece of code. So this section, add JWT bearer, and then we are configuring the JWT using the validate issuer, validate audience, validate lifetime, validate issuer, signing key. These are set to true. And then we've got the valid issuer coming from our app settings file, valid audience coming again from our app settings file, and issuer signing key, which is that key that we captured in that variable. So this adds the JWT bearer authentication handler with detailed validation options. The token validation parameters instruct how the incoming JWT token should be validated. I'm talking about this. This is the token validation parameters, and you are configuring how your JWT authentication will work. So you've got, for example, this parameter, validate issuer. This ensures the token was issued by the expected trusted issuer. So valid issuer. Then you've got validate audience. So this ensures the token is intended for correct audience. So valid audience. Then you've got validate lifetime. Checks if the token is expired or not yet valid. Then you've got validate issuer signing key. So this validates the token's signature matches the expected signing key, which we defined in our app settings file. So valid issuer and valid audience again come from our configuration file to match tokens only issued by your API and intended for the same client. And issuer signing key uses that symmetric key converted based on our secret string in our app settings file to verify the authenticity and integrity of your token. So what does this whole block of code mean? This whole block of code that we added to our program.cs. So this whole block of code is, the way you configure your JWT authentication. So based on this code, the middleware is going to decode and validate the token using the rules that we defined. If the token is valid, the user identity or the claims is set on the request context using HTTP context user. And if it is not valid or the token is missing, the request is rejected or challenged. The next thing that I would like to do is to create a login DTO. So basically the email and password of the user so that the user can log into the system by providing an email and a password. So I am going to create a folder called DTOs. And I am going to create a DTO. The name of that DTO is login request. Okay then. So this login request is a DTO that is going to be used to kind of get the username and password or the email and password of your user when they want to log into the system. So it is like a contract for login input. It specifies what data the API exactly requires so that the user can log in, so the email and the password. This helps with validation, documentation, and clarity. And this decouples the API layer from domain models. So instead of directly using your domain models, like for example, the application user for input, you're using a simplified DTO for login requests. Again, this reduces the risk of accidentally exposing sensitive fields and keeps your API surface clean and focused. Ease of validation. You can apply validation attributes to this class later, like for example, required, email address, and so on, to better help ASP.NET Core to automatically kind of validate the input. And it simplifies model binding. When a login request is sent, typically with JSON data, ASP.NET Core will automatically deserialize that data into this DTO and making your controller code clean and type safe. The next step would be to create the auth controller. So the auth controller is going to be responsible for authenticating a user or kind of allowing the user to log into the system. You see this single action method that we've got here. As you can see, the input is that DTO that we just created, login request. So it's gonna get that request from the body of that request, and then it's gonna decide whether the token, whether the user is has entered the correct username or email and password. And if that's the case, it's gonna kind of generate that token based on the service, using the service that we just created, and it's gonna return that token. So let me go ahead and create this controller in my controllers folder. Before I do that, let me go ahead and rename the file here. So we've got this controller called weather forecast. We're not gonna use this anyway. So what about removing this code and adding my controller here? So the name of the controller is going to be auth controller. We need a dependency on user manager and our service. Remember, we registered our JWT token service in our DI container. We're going to capture our dependencies. And then there is this single endpoint called login, which is going to receive an instance of that DTO, is going to find that user based on the email. If the user is found, is going to generate that token and return it as a response. Otherwise, of course, is going to return unauthorized invalid credentials. So let's talk about this in more detail again. So let's break down the key parts of this auth controller. Basically, I want to focus on that login method and the user manager type, which is using that identity user that we created for this app. So this controller handles the authentication related endpoints. Currently, we've got just one endpoint, login. So it depends on the user manager and JWT token service. JWT token service, we created JWT token service a couple of minutes ago, and it is registered in our BI container. And user manager is our, kind of ASP.NET Core Identities user management service that is going to be used to kind of verify whether the user has entered, a correct piece of, or a correct set of email and password. So user manager application user. This type, user manager, is a built-in identity service that kind of manages things related to users, like, for example, getting a user from your database based on the username. So it is a built-in identity service that manages user-related operations, where the T user, of course, is the custom identity user that we created, application user. It provides many methods, like, for example, finding users by their email, username, ID, checking the password, managing user claims, roles, password, etc. So it is used to find a user by email or verify their password. Then you've got the login method. This is the only endpoint we've got right now. So again, we have specified the method and the route, HTTP post login, right? This method handles post requests to this route. It expects a JSON body deserialized into that DTO we just created containing email and password, right? And then we are going to find that user based on the email. So where is that email coming from? From the DTO we just created. So it tries to find the user in the database by their email address. And then it's going to verify the credentials, validate the credentials. If the user does not exist or the password check fails, it's going to do this. So take a look. Again, our dependency on our user manager. This is one of the methods that user manager provides out of the box. Check password async. It's going to pass the user as well as the password inside of that request. So again, the request is that DTO, right? The user has been probably found here, right? If it has been found in our database, let's check the password. So using the user manager, we're going to check the password based on this user and the password coming from our DTO. So if the user is null or that password fails, the password check fails, we are going to return unauthorized and unauthorized response. So returning HP 401 unauthorized, invalid credentials. Otherwise, we're going to generate the token. This means that the user is found and the password is valid. So let's go ahead and use that JWT service to create our token. So this returns a JWT token string with the user's claims and roles embedded into that token. We already talked about this generate token async in our JWT service. And then we're gonna return an HP 200 OK response with that token inside of the body. And then we can capture that token and we can add it to the authorization header in subsequent requests. So why is this important? This method is the login entry point. When the users want to start using our endpoints, the endpoints that are protected, first they need to log into the system. So it securely verifies the password using identity's built-in hashing and comparison logic, never storing passwords in plain text. It then issues a JWT token if the user is found and if the password is correct. And then the client apps will be able to use that token for their future requests. Now let's test everything. In episode number 2, I guess, we created a couple of roles and users. So one of the users is this user with this email, admin@flywise.com, and this is the password. If again you want to know where we created these users, if you remember in our DB initializer, this is the place where we created our users and our roles, and we assigned roles to we assigned users to roles. So we've got like 3 rows and three users like admin@flywise.com, and the role is, for example, admin, and so on. And of course we've got the password as well. So we talked about these, right, in episode 2, I guess. So let's use this set of credentials, the email and the password of this user, which has the role of admin, to log into the API. And then if the user and the password, the username and the password are correct, we should get a JWT token in our response. So let's do this. I am going to run the API, and then I am going to use Hopscotch to kind of send our request. So I am going to use Flywise API.NET run. So it is building this. The API is running now. I've got Hopscotch, so let me run Hopscotch, and then we will continue. So this is my Hopscotch window. I am going to send a post request to this endpoint of login, and in the body I can put my password and username, of course. So I am going to enter my email and my password. I am going to get rid of this and send my request. So let me send my request and see if I get an endpoint. So let me configure Hopscotch for my local API and continue the video. So I configured Hopscotch. Now I am sending my request. I am sending my request to HTTP, not HTTPS, and then I've got the route, and this is the token that I got. So I have successfully logged into the API now. So this is the status of my response, and this is the token. I can now get this token and add it to the authorization attribute of my subsequent request. And I can, of course, decode this and take a look at the content of this payload as well. This is the website that you can use to kind of decode the token that you got from your API, JWT.io. So you put the token that you got from your API here, and then I have put my secret key here, the secret key from my app settings file. So I've got the payload here. This is the payload, the coded payload. As you can see, I've got the expiration, the issuer, the audience. The issuer is Flywise API, the audience is Flywise users. Then I've got different parts, different keys. For example, the user's email address. I've got the name of that user. I've got the role, and so on. So right now I've got my claim, right? My claim is valid now, and I can use it for subsequent requests. But before we do that, let's continue with the notes. So in the notes, we kind of said that if we send a valid email and password to our login endpoint, we will be able to get our token, and we already got that token. And we can decode that token using this JWT.io. We can decode the header, we can decode the payload, and so on. And we can study the different payloads, the different parts of the payload. I mean, if you want, you can pause the video and study these. I think they're self-explanatory enough. So you've got the name identifier. We already discussed what name identifier is. It is like the unique identifier or the user ID. Then you've got the ID of the user. This is the ID of the user in your identity database. It's like a GUID, right? And then you've got the email address, so key value pairs, right? This is the key, and this is the value. Then you've got the email address, again, the email address associated with that user coming from our database. Then we've got different claims, like for example, name is one of the claims, role is another claim, admin, then we've got the expiration, and then we've got the issuer and audience. So this token now can be saved and used in our client application. So this JWT is a signed proof of our identity. When this token is sent to, when we want to send a request to a protected route in our API now, we can set that token to the inside of the authorization header of subsequent requests, and then send requests to the protected endpoints in our API. So ASP.NET Core will validate the signature, expiration, issuer, and audience of this token. It will build a claims principal from these claims, and then it will allow or deny access to endpoints that are protected. But right now, we do not have any protected routes in our application. We have one controller, one action method called login. But of course, we will be creating endpoints, protected endpoints in future episodes to kind of check whether that token can get us access to those protected endpoints. So the summary of this episode. In this episode, we configure our JWT authentication. We created a login endpoint. We have the DTO now. And then the application can securely generate tokens with user roles. And then we can use that token in our client-side applications. In Postman, in Hopscotch, in your front-end apps, mobile apps, and so on. But again, as I said, we do not have any protected endpoints for now. That will change. In future episodes, I am going to add a couple of protected endpoints, and we will see how the how that token is gonna help us to get access to those protected endpoints. So that was it for this video. I hope you've enjoyed watching it. Again, if that's the case, don't forget to give it a thumbs up, and I'll see you in the next one.